welcome to this coffee chat with Cricket Lou. I'm Kripa Srivatsan, Product Marketing at Infoblox, a leading provider of DNS security solutions. And I have with me a special guest, Cricket Lou. He is our DNS architect and expert and an author. He's written the book DNS and Bind. People line up in trade shows to get signed copies of it. So thank you so much, Cricket, for being here and welcome to the chat.
Thanks, Kripa.
All right. And today in this session, we are going to cover some of the things around DNS and how it can improve security in organizations today. It's a 30-plus-year-old protocol, but malicious actors use DNS all the time to exfiltrate data, spread malware, and we'll cover some of the things that you can do to improve security using DNS in organizations. So with that, Cricket, I know you've been doing this work for quite a long time. How did it all begin? What's the evolution of DNS, and where are we today?
Well, that's a good question, Kripa. I would say that sort of the seminal moment in terms of the evolution of DNS security, at least from my perspective, was back in 2008, where my friend Paul Vixie came up with this idea of response policy zones. Before that, we had dealt a little bit with DNS security. We developed, for example, the DNS Security Extensions, which are mostly about being able to cryptographically validate DNS data. But other than that, we had mostly concentrated on transactional security, like access control lists that determine which IP addresses are allowed to send queries to a name server or do zone transfers from a name server. And response policy zones were really the first mechanism that gave us any kind of contextual security. So they allowed us to say, hey, these are domain names that we know are being actively used maliciously out on the internet right now. And if you receive a query for one of these, you shouldn't answer it. You should respond with, for example, an error that says, hey, that doesn't exist, or something like that.
Yeah, that's really interesting. And do you see people adopting RPZ, or the response policy zone, as you mentioned, a lot, or kind of where is it in terms of awareness?
I think there's increasing awareness of response policy zones. Certainly from our vantage point at Infoblox, we see a lot of folks adopting response policy zones. But I'd say if you looked out at the organizations, more broadly than just the organizations who are our customers, you'd probably see the adoption is still pretty low, probably single digits, which is a little bit sad because there's so much potential in response policy zones.
Right, and we know that DNS is ubiquitous. Everybody needs it for their business to function, and it's actually a great place to implement some malware control, because you can scale the protection, right, all through the network, and it's a fast, easy, and early way to detect malware.
Right, and you already have this infrastructure in place, right? Everybody who runs a big TCP/IP-based network already has DNS servers, and so if you can plumb RPZs into them, that's fantastic, right? It's not a bunch of new devices that you have to acquire and deploy in distributed fashion on your network. It's infrastructure that's already there.
Right, that's interesting. And does it use blacklists or threat intelligence feeds? What goes into that infrastructure?
Into a response policy zone infrastructure. You can plumb basically anything into it. The nice thing is that a lot of organizations that were sort of traditionally in what we would call the DNS blacklist or DNS blocklist business have started to make their reputational feeds available via response policy zones as well. So now you have the option of going to Serval or Spamhaus or Farsight Security or any number of different RPC providers and subscribing to a response policy zone that suits your particular purposes. One that you could use for anti-spam measures, one that you could use, for example, to prevent your users from going to newly observed domains, which is what Farsight does.
That's really interesting.
Before we get too far, I did want to remind people that they are able to submit questions to us via the Q&A. Is it the Q&A facility in the interface?
Yes, exactly. Thank you for bringing it up. So you can submit questions as you're listening to us on the Q&A window in your browser. So next question, it's great, our response policy zone using blacklist, threat intelligence feeds, newly observed domains, great way to detect malicious activity and infrastructure. What about analytics? I mean, these days, it seems like everybody is incorporating some sort of machine learning or analytics into their security products. Is there a place for analytics in DNS security?
Yeah, there definitely is. So Response policy zones are very good for carrying what I'd refer to as reputational data. So for example, if you know, because you received some spam email that was part of a phishing campaign, if you know that a domain name is actively being used in a phishing campaign, you can put it on a response policy zone and prevent people from going there. But sometimes it's not as obvious that a particular domain is being used maliciously or not. Sometimes you need to look at, say, the pattern of use, if you will. And that really requires analytics. One of the pioneers in developing the infrastructure that allows us to do analytics was a German named Florian Weimar. And back in 2004, Florian came up with this idea that we now call passive DNS. Passive DNS is basically a record of all of the responses that big name servers around the globe receive from other name servers. So they get a collection of referrals to other name servers and answers and errors and things like that. And passive DNS basically is a system for aggregating all of that into a big database somewhere. But if you have that big database of this basically telemetric data from DNS, you can do some amazing things by analyzing it. You can find, for example, domain generation algorithms. Even domain generation algorithms for which you have no sample of the malware that uses it. But just by the patterns of queries received across these various name servers, you can say, aha, there's a domain generation algorithm at work synthesizing these domain names, conducting these lookups, and it indicates that these IP addresses are infected.
Okay, that's really interesting because you don't always, like you said, malware keeps changing its behavior, changing its signature. So using signatures and reputation is probably not the only approach, right? You need to augment it with some sort of analytics that can detect these patterns as they evolve.
That's right.
What about data exfiltration? We know that the crown jewels for any organization is their data, and everybody wants to get their hands on it, especially the malicious guys.
Yeah.
So, and I've read articles, I've read reports that say that DNS is actually one of the back doors through which data can be exfiltrated, because organizations are putting in email security, web security, they're blocking all those layers, but DNS is always left open, right? So can data exfiltration be detected and blocked using these type of capabilities?
Yeah, absolutely. I think data exfiltration, or put more generally, DNS tunneling, is one of those types of potentially malicious activity that's easy to identify, or relatively easy to identify using analytics. Now, sometimes, if you've seen a particular form of DNS tunneling before, you can catch it by its signature. You know what encoding mechanism they use, or something else that sort of highlights that traffic in among a larger stream of data. But other times, you actually have to look at things like the entropy in responses or in query names. You have to do things like n-gram analysis. And that way, you can suss out DNS tunneling even when you've never seen that particular brand of DNS tunneling before. And we've got products that do that, as you well know.
Yep, that's true. As Cricket mentioned, having all these different capabilities, complementing your RPZ with analytics, detected exfiltration, DNS tunneling is a highly recommended approach. And DNS tunneling, there are legitimate use cases for DNS tunneling. Right? Many endpoint software use DNS tunneling to communicate between the endpoint and their servers, for example. So I think where analytics can help is discerning the legitimate DNS tunneling versus the malicious DNS tunneling.
That's right.
Great. The other thing I think we always recommend, and Cricket knows this too, is that it's great to have DNS security in place and block the bad stuff, block the malware, block the data exfiltration. But you also don't want to do it in a silo. You want to make sure that you're notifying the rest of the security tools that somebody may be using in their networks. For example, vulnerability scanners, endpoint security, NAC solutions, right? And we've seen some use cases that are really, really popular. So for example, let's say we detect something at the DNS layer, we block data exfiltration. It's great we blocked it, but that endpoint or that laptop is still infected, and something needs to be done to clean it up. So we can automatically notify a vulnerability scanner in real time, right, when we block it, and say, if there's something malicious going on with this endpoint, you may want to go scan it for vulnerabilities, for example. Or you can tell the NAC solution to go knock it off the network and don't allow it back until it's cleaned up, right? So those are some popular use cases we've seen, as you very well know, Cricket.
Yeah, I mean, one of the things about DNS is as near and dear it is to my heart, DNS is not sort of the be-all, end-all security solution, but it can play a really important role. And sometimes that role is detecting infection because, for example, we get a query that we know for a domain name that we know is, say, the command and control server for a botnet or something like that. And sometimes we're an enforcement point. Sometimes we're in the position of saying, hey, you don't get to get any responses from DNS because you're infected. But we have to cooperate with other systems in order to do that. It's obviously a sort of great big wide world out there of security solutions, and if we detect infection, sometimes we need to communicate with something else, like say Cisco ICE, and say, hey, you need to quarantine this device for the time being because apparently it's infected. Sometimes we're in the position of augmenting data. Another system will say, hey, it looks like I see malicious activity from this IP address. What can you tell me about that IP address? What OS is it running? Who's logged in? That kind of stuff.
That's a great point. Yep. And I think that the other thing that DNS and the other solutions like DHCP and IPAM can provide is network context, right?
Yeah.
With the IPAM data, with the DHCP fingerprinting data, we can actually tell the criticality of the infected asset. Is it somebody's laptop? Is it a production system that is running critical applications? Which endpoint is actually doing this malicious activity?
Right.
So now the security admins or the operations teams get more visibility and they get more context,
That's
so
right.
they can prioritize the response.
Yeah.
So I think that's critical.
We did get a question that came in
Okay.
from the audience, which is, I think, relevant to our discussion of response policy zones and analytics to a certain extent, which is, won't a next-generation firewall catch DNS-based malware? So that's an interesting question. Why RPZs and not just relying on my next-generation firewall to do this?
So that's a good question, and we get that a lot. Next-gen firewalls are great for what they do, sitting at the perimeter, checking for malicious activity, and protecting basically the perimeter. But let's say you have employees or users in Starbucks, or let's say they're at home. Their next-gen firewalls are not protecting their endpoint at that time. Right. So they could still be going to malicious sites inadvertently and then download malware, and then they bring it back into the office on Monday morning. Now they brought in an infected device within the firewall, right? So that's one use case where the firewall can be bypassed. The second thing is that firewalls typically sit, as I mentioned, at the perimeter, so they're far away from the endpoints. So they don't really see, even if they see some malicious queries coming in, they don't really see which endpoint is making that query because they get it from like a downstream server.
That's right.
So DNS is actually close to the endpoints. So when you do it at the DNS level, you actually get that endpoint visibility.
Yeah.
So those are a couple of reasons I think that we're not saying get rid of your next-gen firewalls, we're saying complement it with a DNS security solution.
Yeah, I like to refer to that second use case as triangulation, because as you say, the next generation firewall is often at the periphery of the network, connecting your network to the internet. And if it has the capability to identify malicious queries or queries for domain names that are being used maliciously, all it sees, because of the way the DNS protocol works, is the last server to touch that particular query, which isn't necessarily anywhere close to the infected device. The infected device may be back here, and you may have forwarded the query up through several different DNS servers, and all you see is, well, this is the last forwarder in the chain. So working your way back to the original infected device can be pretty challenging. Yeah. So DNS servers, if you've got your local recursive DNS server plumbed with an RPZ that'll identify that query, then you're going to be in much better shape. Identification of the client is like that.
Yep, very true. What other questions do we have?
We also have a question about what other security tools we integrate with.
Okay,
that's a good question
great.
for you, not for me.
As I mentioned earlier, DNS security is not complete unless it integrates with the rest of the security ecosystem. Security operations teams are always struggling with thousands of alerts every day. They want to know that their tools are working together and they're not chasing their tails, so to speak, right? So where some of the security solutions or some of the other tools we integrate with include, like I said, vulnerability scanners, including Rapid7, Tenable, and others. NAC solutions like Cisco ICE that you mentioned. We integrate with endpoint security. We integrate with web gateways, for example, with McAfee. We integrate with threat intelligence providers. I think our threat intelligence also comes from 25, 28 different partners and sources that we have, including government and educational universities and things like that.
That's great.
So yeah, I mean, we integrate with most of the security categories of security tools that organizations use today, right? So I think that's really important when you think about making your security ecosystem work better. And the other thing that we do is, because we give them this data, because we give them visibility into DNS-based threats, we're actually improving the ROI on these tools that they've already purchased, right? That the customers have already purchased. So that's important, right? You're using your infrastructure that you already own, your DNS, and you're actually improving the ROI of the security tools that they already own.
Yeah,
so
great.
That's a win-win.
We have a new question from Paul Cole, who says, can we do DNS blocks in Infoblox? And I think that what he's probably referring to is being able to block things via response policy zones. That's what I read into that anyway. And certainly the answer is yes, absolutely. We support response policy zones. The nice thing is that response policy zones are kind of a vendor-neutral format. So you can turn on the response policy zone mechanism on your Infoblox appliances and then plumb in response policy zones from any one of a number of different providers. And in addition to that, of course, you can configure your own response policy zone just for your organization that gives you direct control over what you want to block, what you want to redirect to other places.
Yep.
Which is pretty powerful. Let's see. Looks like Amin says, do you integrate with Trend Micro antivirus?
Okay, so we don't do that today, but definitely, we have a lot of other security vendors in the pipeline, other tools, other categories of integrations that we're working on. So not today, but maybe in the future.
Yeah, we've taken kind of a neutral approach, I think, to partnering. I mean, we're happy to partner with whomever. It's really just a matter of having the cycles to do the integration internally. We don't really have any particular bias. We're not part of sort of one ecosystem or another.
Exactly. You're definitely vendor neutral. We want to make sure that we integrate with the leading tools that customers are using. And we're always talking to customers about the use cases they're trying to solve, right? So if that makes sense, we will do it, right?
Yeah.
So it's definitely, we keep adding more and more. And like you said, we don't prefer one over the other. So vendor neutral, yeah.
Right. We have a question here, which is near and dear to my heart, which is, if DOT and DO are widely adopted, do we still need DNSSEC? And so I think we're going to have to unpack this one a little bit, because we have to explain what DOT and DO are first. And I don't know if we can even assume people know what DNSSEC
It would be good to explain, yeah.
Probably with this audience, we can expect them to know generally what DNSSEC is. Yeah. But DOT and DO are relatively new. DOT and DO are new encrypted transports for DNS, and DOT is an abbreviation for an acronym for DNS over TLS. TLS is the successor to SSL, used for basically channel encryption, and then DO is DNS over HTTPS, same protocol that you use to access most websites. And the idea behind DOT and DO is that it allows you to encrypt the channel, in particular between your stub resolver, which is on your, say, laptop, mobile device, or what have you, and that recursive DNS server that it queries. That's been sort of a missing link in the world of DNS for a long time. We went to a lot of trouble developing and deploying DNSSEC, the DNS Security Extensions, to try to give people the ability to cryptographically validate DNS data. So to prove its authenticity and its integrity, so that when you look up, for example, the IPv4 address of www.google.com, you know, hey, this is the real IPv4 address that Google actually digitally signed. It hasn't been modified since it was signed, even if I retrieved it from a cache that I might not specifically trust. That is really powerful, but really that goes from sort of the recursive DNS server that does the validation on to the authoritative name servers that it communicates with. And we didn't do anything for the longest time for what we call that last mile between the stub resolver and that first hop recursive DNS server. And so DOT and DO are really designed to secure that, to enable you to say, I know which recursive DNS server it is that I'm communicating with, and I also know that the same data that it sent me is what I retrieved on the other end. Mm-hmm. So they're kind of complementary, really. You don't want one without the other. You know, for example, if you just had dot or doe, well, you wouldn't necessarily know that the data retrieved by the recursive name server on the other end had been cryptographically validated, right? It could still return bogus cache poison data to you. And conversely, if you had DNSSEC but no dot or doe, well, that recursive DNS server, if it had been compromised for whatever reason, or if there were a man-in-the-middle attack, you wouldn't know that.
True.
So those two are, I would like to think, complementary. I don't want anybody to give up on implementation of DNSSEC just yet. Cool.
All right. That's interesting. So let's talk about the future of DNS, right? Mm-hmm. So let's say, you know, companies are doing hybrid cloud, they're trying to implement SDN and new architectures, right? What's the role that DNS has to play as the world is evolving, as the networks are evolving and getting more complex, actually?
Well, it's interesting because the whole SDN question, I'm no SDN expert, and I don't pretend to be, but as I understand it, one of the real raisons d'etre of SDN is that you're taking advantage of relatively high-speed internet access instead of private connections back into a company's network. Mm-hmm. So preferentially being able to use high-speed consumer-grade internet access rather than, say, MPLS. But one of the things I didn't realize is that really, in order to take maximum advantage of that, you have to have a fairly sophisticated DNS infrastructure that goes out to I'm thinking mostly of SD-WAN in this case, but mostly out to the SD-WAN layer, so that SD-WAN devices can say, hey, you know, I'm going to send a DNS query. If that DNS query is for a domain name that's in my organization's internal namespace, this needs to go one way. If, on the other hand, it's for something in the internet namespace, it needs to go directly out to the internet, so that, for example, content delivery networks and things like that can make a determination of which answer to send me based on my real source IP address. Right?
Okay.
It sort of defeats the purpose to have all of this SD-WAN traffic, all the DNS queries funneled back through some central, some central data center within a company, and then out to the internet, because those CDNs are going to give you answers that are appropriate for whatever the last forwarder was, which are not necessarily anywhere close to the actual SD-WAN endpoint.
Right. Okay. Cool. And where do you see DNS security in the future? Do you see it more evolving, more analytics, more in the cloud, delivered as a service? Where do you see the industry going, and where do you see the vendors going?
Well, certainly we've seen a big push towards more and more cloud-based DNS infrastructure. I think one of the first parts of the DNS ecosystem to move to the cloud was internet-facing authoritative DNS service. And there are a lot of companies out there that made a lot of money on that. There's Newstar, which was really one of the pioneers with Ultra DNS. There's VeriSign, Dyn, NS1, lots of companies that do a very good job of internet-facing authoritative. And then over the last several years, we've seen the rise of these sort of big cloud-based recursive DNS providers. So we've seen Quad9, and we've seen Cloudflare's Quad1, and Cisco's OpenDNS, and our Active Trust Cloud offering. So all of these are big central recursive DNS servers, all of which have a somewhat different value proposition, right? OpenDNS and Active Trust Cloud are about configurable security policy designed to protect users from going to bad places. Quad9 is less about that. Quad1, Cloudflare is mostly about like privacy, making sure that we don't reveal what it is that folks are doing, but less about like configurable security policy. So I think that's going to continue, and of course we have some big projects in the cloud realm too. Yeah. Beginning to offer more and more infrastructure services from the cloud, or at least managed from the cloud.
Yeah. I think that's a critical point you mentioned, managed from the cloud, right?
Yeah.
I think cloud managed services definitely are getting more and more popular, more ubiquitous today. As you mentioned, we have our Active Trust Cloud offering, which provides DNS-based protection in the cloud.
Yeah.
So meaning that users everywhere are protected, either on premises or roaming or in their at-home offices, things like that. The other thing I also see is customers are not entirely moving to the cloud. They still have on-premises infrastructure.
Oh, yeah.
A lot of their security ecosystem is on-premises. So I see this notion of a hybrid model being a more viable solution for a lot of our customers, where they can use the cloud services for scale, for catching more stuff, doing more analytics in the cloud, but then also pushing enforcement on their on-premise boxes so that they can do on-premise enforcement, but also integrate with the rest of the ecosystem on premises and capture a lot of that data that's available on premises, including the contextual data. So I think that's another interesting trend that we've seen as well. The other thing, another use case that I've seen is also complementing DNS security with, let's say, a web gateway solution, right?
Yeah.
Web gateway solutions are quite expensive, if you complement a DNS layer security and then block all the known bad stuff immediately at the DNS layer,
Right.
and then forward the rest of the queries to a web gateway solution, you're now offloading some of that processing from the web gateway and doing it at a more cost-effective way at the DNS layer.
Right.
And then you're leveraging the web gateway for more deeper content inspection and things like that. Do you see that as a good use case as well?
Yeah, I mean, certainly we have that kind of integration with McAfee, so I think that's a good thing. It's nice also, I think, in terms of efficiency, in terms of latency, because if you use DNS to make the black and white decisions, this is definitely a bad domain name, this is definitely a good domain name, that's a much faster decision than pumping things up through a secure web gateway. You use the secure web gateway only when you have to for those sort of gray areas, like, well, depending on which URL you go to that starts with this domain name, that may be malicious or that may be benign. Okay. So I think that's a big improvement.
Cool. Well, I think we have time for a couple more questions.
We do have a couple. Here's a good one for you. Do we have any integration with next-gen firewalls such as Palo Alto?
Yep, absolutely. So good question, and thank you for bringing it up. So we do have integration with Palo Alto Firewall. One of the things we offer is, as I mentioned earlier, our threat intelligence is gathered from multiple sources, several of threat intelligence partners, and we put it all into this platform called TIDE, or Threat Intelligence Data Exchange. And what you can do with that TIDE platform is you can use that threat intelligence from the TIDE platform into Infoblox DNS Security. Or you can also send that threat intelligence in a consolidated fashion to other security tools like Palo Alto firewalls. So we actually allow a threat intelligence to be pushed into a Palo Alto firewall, for example. So that's one integration we have with them.
Yeah. And Kit asked, can you dive a little deeper into fast flux and DGA detection capabilities? Those are analytical algorithms, generally speaking, that run over passive DNS data. The nice thing is that detecting fast flux is relatively easy, because what you're doing is you're looking at all of these different name servers, viewpoints on domain names and which IP addresses that they map to over time. And all you have to look for is a particular domain name that changes its name to IP address mapping very rapidly. And then you sort of have to factor out those domain names that are managed by content delivery networks and those that are doing some interesting load balancing tricks on the back end. If you do that, what falls out after you filter out the benign stuff is, generally speaking, fast flux. DGA detection within analytics, there's been some interesting work done there. We used to have a partnership with Georgia Tech, and there's a lab there, the Astralavos lab, run by a professor named Manos Antonakakis. Hi, Manos, if you're out there. And Manos and his students have done a fantastic amount of work detecting DGAs, even when, as I said before, even when they don't have any particular specimen of the malware that uses the DGA. But they use very sophisticated things that are beyond my meager mathematical capabilities, like, I'm trying to remember what it was. Hidden Markov models was what I read about in order to detect sort of sort of DGAs operating within a larger corpus of passive DNS data. And Kit, if you're really interested, you can actually go and find some of the papers that Manos and his graduate students wrote about detecting DGAs within passive DNS data. They're downloadable for free.
Okay.
So what do we have next? We have, here's one that I'm afraid I have to field, which is a question about whether or not there's a new edition of DNS Bind coming out. And I'm embarrassed to say that unfortunately no 6th edition is immediately forthcoming. One of these days I'm going to actually have enough time to work on it. Until then, my sincerest apologies to those of you who are still muddling by with the old 5th edition. But at least the DNS theory material is still more or less current. I know it's missing a lot of material. I think our time is just about up, though, isn't it? So,
yeah, it is just about up. So thank you, Cricket. I know we covered a lot of ground today. So thank you so much for the insights. So October is Cybersecurity Awareness Month. So we will be having a lot of thought leadership blogs, deep insights into some of the things we discussed today on our community site, so community.infoblox.com. So, definitely some good information coming everybody's way. So thank you so much, Cricket, for the coffee chat.
of course, yeah, thanks, group.